Welcome to an extraordinary journey through time and space as we explore the fascinating 400-year history of telescopes. These remarkable instruments have revolutionized our understanding of the universe, allowing us to peer into the depths of space and uncover the secrets of distant galaxies, planets, and the very origins of our cosmos. Our story begins in the early 17th century, a time of great scientific curiosity and innovation. The first telescopes, known as refracting telescopes, were created by Dutch spectacle makers. These early instruments consisted of a pair of lenses, a convex lens at the end of the telescope and a concave lens at the viewer's end. Initially, these telescopes were primarily used for terrestrial observations and military purposes. It was the Italian astronomer Galileo Galilei who first turned these small spyglasses towards the heavens, forever changing our view of the cosmos. In 1609, inspired by reports of Dutch and Danish telescope makers, Galileo constructed his own telescope. His first instrument offered a mere 3 times magnification, but as he refined his design, he eventually created a telescope capable of magnifying objects up to 30 times. Galileo's observations were groundbreaking. He discovered the 4 largest moons of Jupiter, observed the phases of Venus, and made detailed observations of the moon's surface. His drawings of the moon, published in his work Sidereus Nuncius, the Starry Messenger, in 1610, revealed mountains and craters never before seen or imagined. The next significant advancement came from German astronomer Johannes Kepler. He improved upon the convex-concave design with a pair of convex lenses. This offered a wider field of view and higher magnification, although it produced inverted images. Telescope makers implementing Kepler's design were able to achieve magnifications of up to 100 times, with telescopes as long as 45 meters. However, these long tubes proved unwieldy in windy conditions and bad weather. A revolutionary change in telescope design came from Sir Isaac Newton in 1672. Newton introduced a new type of telescope based on reflection, or curved mirrors, rather than refraction through lenses. These reflector telescopes could capture more light and avoid the dispersive prism effect, known as chromatic aberration, which occurs when light passes through a lens. Newton's design used a concave primary mirror to gather light and a small, flat secondary mirror to reflect the image to an eyepiece on the side of the tube. This design, known as the Newtonian reflector, is still popular among amateur astronomers today. In the same year, Laurent Cassegrain further refined the reflector design. His telescope used a concave primary mirror with a hole in the center and a convex secondary mirror that reflected light back through this hole to the eyepiece. This design allowed for a long focal length in a compact tube and is the basis for many modern reflecting telescopes. As we move into the late 18th century, we encounter the work of Sir William Herschel. His telescope design featured a large primary mirror and an eyepiece mounted off-axis, eliminating any obstruction in the light path. This allowed for larger mirrors and greater light-gathering power. With one of his telescopes, Herschel discovered a new planet, which he named Georgium Sidus, in honor of King George III. This planet was later renamed Uranus. Herschel's observations and detailed drawings of nebulae published in 1912 significantly advanced our understanding of these cosmic objects. The 19th and early 20th centuries saw a trend towards ever larger telescopes. The Great Paris Exhibition Telescope of 1900, built by Paul Gautier, was an enormous 57-meter-long reflector with a 1.25-meter diameter mirror. While impressive, it was more of a showpiece than a practical instrument. A more significant development came in 1917 with the Hooker telescope at Mount Wilson Observatory, designed by George Ellery Hale. With its 100-inch or 2.54-meter diameter mirror, it was the largest telescope of its time and greatly advanced the study of galaxies and nebulae. It was using the Hooker telescope in the 1920s that Edwin Hubble made observations leading to our understanding that the universe is much larger than our galaxy, and laid the groundwork for the Big Bang theory. The next great leap in telescope technology came with the launch of the Hubble Space Telescope in 1990. Developed by NASA and the European Space Agency, or ESA, Hubble is a reflecting telescope with a 2.4-meter mirror orbiting above Earth's atmosphere. It has provided unprecedented clarity and detail in its observations of the universe, revolutionizing our understanding of cosmic phenomena. Hubble's images have become iconic, showing us the birth and death of stars, the collision of galaxies, and the existence of dark energy. It has helped us refine our estimates of the age of the universe and has been crucial in the study of exoplanets. The most recent milestone in telescope technology is the James Webb Space Telescope, launched in 2021. A collaboration between NASA, ESA and the Canadian Space Agency, Webb is the most powerful and complex space telescope ever built. With its 6.5-meter segmented mirror, it operates in the infrared spectrum, allowing it to observe distant galaxies, exoplanets and other celestial phenomena with extraordinary sensitivity. Webb is positioned about 1.5 million kilometers from Earth at the second Sun-Earth Lagrange point, or L2, where it orbits the Sun. Its advanced capabilities allow it to look further back in time than any previous telescope, observing some of the earliest galaxies formed after the Big Bang. As we reflect on the 400-year journey of telescope technology, we can see how each innovation has expanded our cosmic horizons. From Galileo's first glimpses of Jupiter's moons to Webb's deep infrared views of the early universe, telescopes have continually pushed the boundaries of human knowledge. These instruments have not only advanced our scientific understanding, but have also captured the public imagination, inspiring generations to look up at the night sky with wonder and curiosity. They have shown us the beauty and vastness of the cosmos, reminding us of our place in the universe. As we look to the future, new telescope projects are on the horizon. NASA's Nancy Grace Roman Space Telescope and the ground-based extremely large telescope in Chile promise to further expand our view of the cosmos. Who knows what new discoveries and insights these instruments will bring? The story of telescopes is a testament to human ingenuity and our enduring quest to understand our place in the universe. As we conclude our journey through the history of telescopes, we're left with a sense of awe at how far we've come and excitement for what the future holds. The universe is vast and full of mysteries, and with each new generation of telescopes, we move one step closer to unraveling its secrets. So the next time you look up at the night sky, remember the incredible journey of discovery that brought us to this point, and imagine what wonders still await us in the cosmic ocean.